The major product of the following reaction is given by. Here in the given question, a cyclobutyl system and the cyclopentyl system are connected to a carbon having one hydroxy, and these are participating in acidic medium followed by heating conditions. We are expected to write the major product of the transformation. Whereas as being acidic medium, H plus ion day 2 bond formation takes place between this and this. If I write it as a single bond, this will become electron deficient. Whereas as water molecule, it is eliminated because H2O plus is acting as good leaving group. Hence this will becomes what? Cationic in nature. This is 5-membered system, and the next one is what? 4-membered system, like this. Whereas 5-membered system is relatively stable, hence as being 4 is less stable. So 4 participates in ring expansion in the form of rearrangement. As a result, this 4-membered system is also converted as one of the 5-membered system, like this. And this one, once again, it is a 5-membered system. From the beginning itself, it appears as like this. Whereas let us expect this bond is broken like this as carbon ion. This is dou negative, this is dou positive. This carbon ion converted as complete carbon ion and made a contact with this carbocation, implies this particular carbon becomes what? Electron deficient. Law of conservation of charge. Cation remained as what? Cation over there. Now after, as being it is maintaining its cationic nature as it is, as being it is secondary, there is a chance for it to be converted to stablest cation, hence it participates in hydride ion shift from the adjacent position, thus it is converted to the new system, that is here the cation is shifted. After shifting to this particular place, this is cyclopentyl, this is cyclopentyl. Both cyclopentyls are present adjacent to one another with one sigma connectivity. Both comes in different planes because it is a planar system. It is also approximately planar system. Due to this heavy strain, once again one of the cyclopentyl system broken, as this is plus in charge, this is minus in charge, and it was, let us assume, completely broken as C minus. C minus make a contact, broken, and it makes a contact with the cation, and it is converted as 6-membered ring system. Thus it appears as a 6-membered system connected to 5-member system. This is 5-membered system, whereas on this 6-membered ring system, here it is having what? Positive in charge. Whereas once again this is 6-membered system having positive charge, this is 5-membered system. So as being 5-membered is a cyclic system offers strain, it is also broken like this. Let us feel this as positive, this as negative. This bond was broken and once again makes a contact with the 6-membered ring system, and it appears as this 6 remains as it is here. Whereas on the adjacent position, this 5th carbon atom is making contact. Let us feel these are the positions. This is this and this is this. It once again becomes another 6-membered ring system associated with one of the carbon in them. Connected carbon is having what? Positive in charge. Whereas this particular one participates in elimination reaction because cation no more stable for long times. On heating, it loses another one H in the form of H minus, will results into the formation of what? Double bond formation. Thus it results into the formation of not the single bond between the two rings, it results into the formation of a double bond. That is, from here H in the form of H plus is eliminated on heating conditions, converted as carbon ion. This carbon ion and this carbocation, and this carbon ion both combines with one another, results into the formation of what? Bicyclic 6-membered double bond connected system formation takes place. Once again, if I repeat, so therefore this is in presence of H plus converted as cation. 4-membered is having lot of strain, and it expands, participates in ring expansion. Like this you can also write here. If I give the numbering, so therefore this is 1 and this is 2, this is 3, this is 4, and this is 5. This one in them will becomes here. 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. Like this, 2 5-membered rings, 2 5-members having different planes. So therefore once again expansion, in expansion one will participates, converted as 6-membered ring. 6 is also feels strain with respect to the cyclic 5-membered, having chance is there, hence it also expands and converted to bicyclic system. There it participates further on heating in elimination of H plus, results into the formation of double bond associated bicyclic system, combination takes place. The next question is regarding the possible number of alkenes as the products formed in the elimination reaction of the alcohol in presence of acidic medium by using sulfuric acid followed by heating conditions. And the question related components conditions can be given by, yes, the alcohol that is provided for us is like this, and it is subjected for the acidic medium followed by heating conditions. And with the help of the possible stablest cation, you are asked to write all possible products including stereoisomerism, the how many varieties of products are formed in this transformation were asked for us for the calculation. Whereas if I give the numbering and the name for this particular compound, this will becomes pentane related compound, pentane 3-ol, whereas this is having 2 comma 2 comma 4 trimethyl, 2 comma 2 comma 4 trimethyl pentane 3-ol is the compound. 2 comma 2 comma 4 trimethyl pentane 3-ol is the compound. This is subjected for acidic medium conditions like sulfuric acid followed by heating. When it is subjected for acidic medium conditions followed by heating, that H plus comes very close to that of the lone pair, as being it is positive charge. This will become H2O plus. H2O plus is eliminated. That is the nature of the sulfuric acid to make any hydroxy group as cation. So therefore, after being it is acting as a good leaving group, leaves from the system as water molecule, thus it is converted as a stablest cation. This is possible secondary stable cation formation takes place. Now it is having two chances. It is having hydrogen, it is tertiary carbon. It is doesn't have hydrogen, it is what? Quaternary carbon. Compare it to the secondary. From one side tertiary becomes stable, from other side quaternary becomes stable. So it is having two chances to participate in the rearrangement. One with respect to the tertiary hydrogen as hydride ion transformation takes place. Thus there are two varieties of rearrangements. In the first rearrangement, what happens is from here H as H minus will be shifted. Thus it becomes H. It becomes H followed by what? This will becomes cation. Tertiary carbocation is generated. In another way of rearrangement, what happens is from here methyl anion transformation, that is shifting takes place. As a result, it becomes tertiary followed by, now it is having hydrogen. Now it is reached to methyl followed by dimethyl system is present over here. This is tertiary carbocation. This is also what? Tertiary carbocation. In one in case hydride ion shift was occurred and it is converted to corresponding tertiary carbocation like this system. In this case, one in them is possible. Methyl minus shift is possible, shifted and it is converted to corresponding tertiary carbocation. Both are different. From these two cations of the tertiary and the another tertiary, different varieties of products formation takes place. By taking one particular ion followed by the other, we will write all possible varieties of the products formed in the transformation. These are the cations. Whatever the cations are formed over here, once again I wrote on the board. This is cation 1 and this is cation 2. Corresponding products I am writing. Suppose from here we are doing heating condition. Heating conditions also favors for the Hoffman elimination, which is major compound. So from here or here, if elimination takes place, that results into the formation of what? Hoffman product. This will be the Hoffman product. Whereas regularly, as a major product, that is Sedgwick elimination takes place, Sedgwick product formation takes place, and this will be the Sedgwick product. Like this, two varieties of compounds formation takes place, and this center is not a chiral center, hence this is one compound, this is one compound. Here two alkenes, two different varieties of compounds formation occurs. If I go for this cation, here also we have chances to form the Hoffman product as well as the Sedgwick product. If I go for the Hoffman product, this is Hoffman product. So this is methyl followed by isopropyl group is present, but this center will become chiral center because it was just shifted onto the carbocation. It is having R configuration and it is having S configuration. There is no geometrical isomerism. Similarly, suppose if Sedgwick elimination takes place, it is also having hydrogen. So therefore, from here H in the form of H plus is eliminated, suppose, then that results into the formation of double bond followed by this one. Whereas there is no chiral center, hence here one compound formation takes place, here two compounds formation. Total in this way of carbocation results three compounds. In this way of carbocation results two compounds. All together on mixing one with other, five varieties of compounds formation takes place. So the total number of possible compounds formed from the 2, 2, 4. Trimethyl pentan 3-vol system offers 5 varieties of alkenes. Out of them, 2 are found to be what? Enantiomers to one another. Remaining all are normal stereoisomers are formed, that is geometrical isomers are formed. These 2 are the compounds, doesn't have any kind of stereo centers, only 2. From this carbocation, one is forming having chiral center, hence enantiomers are formed, and other is, that is edge of normal compound is formed. So this is 1, these are 2 by counting, and these are 2, total 2 plus 3, 5 varieties of alkenes formation takes place.